We are going to the moon, to deep space, and to Mars. Humanity will venture further out into our solar system than ever before. But the history that awaits us requires a first step.
This is a story of a mission that represents that essential first step to the moon. A mission that has become the first in a series of increasingly complex missions to expand the bounds of human exploration. This is the story of Artemis I.
3, 2, 1. Boosters in ignition. And liftoff of Artemis I. We rise together back to the moon and beyond.
Artemis I was a first flight that set new records of performance, exceeded our estimates for efficiency, and established new safety baselines for human flight into deep space. All before returning from this journey, plunging through Earth's atmosphere, and arriving safely back on our home planet.
The stakes riding on this mission technically, politically, programmatically, were higher than anything I've ever witnessed. Anything less than the perfect operation of over 2 million parts that make up the Orion and SLS space vehicles, as well as the execution of tens of thousands of procedures during the flight. And it's likely that this generation, our generation, we lose the moon. And yet, as a first test flight of an entirely new spacecraft for over 25 days and crossing 1.4 million miles, Artemis I flew a near-perfect mission to the moon and back, flying a human-rated spacecraft in deep space, farther and faster than ever before. The launch of Artemis I on November 16th, 2022, was a demonstration of new generation of capabilities and powerful performances.
That night, the Block 1 version of SLS became the most powerful launch vehicle ever flown to orbit. SLS roared to life with 8.8 million pounds of thrust. That is 1 million pounds greater than even the mighty Saturn V.
To all personnel, STC,
STC spell.
OTC, GTC, MCO.
Booster, go. Control, go. GNC, go. Prop, go. CDH, go. FIDO, go. FAM, go. MPO, go. All right, folks, go for launch.
At this time, I give you a go to resume count and launch Artemis I.
And here we go.
10.
Hydrogen burn-off igniters initiated. 4-stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis I.
We stood only 3 miles away from the launch pad, and when that countdown clock hit 0, the SLS lit up the sky like daylight. And we were treated to the ground and air reverberating the power of that first stage through our bodies. The crackling of the engines and the solid rocket motors was so distinct and even louder than when we launched space shuttles from that very same launch pad.
Confirmation that the solid rocket boosters have separated.
And then hearing the collective gasp of the crowd when we finally heard MECO, main engine cutoff.
The flight dynamics officer reports that we have a nominal main engine cutoff.
And everyone could finally breathe again. The first stage had done its job. That's a moment we will never forget.
Performance nominal. Copy nominal. Booster, how's the engine looking?
Looking good, flight.
Okay, FIDO, straight and narrow.
The technical perfection of this launch was equally as staggering. Artemis I achieved orbital insertion with an accuracy of 99.974%. That's a near perfect velocity bullseye, and a level of precision never flown before on a first flight.
The groundbreaking performances of this mission were highlighted further when the ICPS, or second stage, powered Orion through the perigee raise maneuver, followed by the translunar injection, or TLI burn. They put Artemis I spacecraft on a near-perfect trajectory to the moon.
Flight control, ICBS is in attitude control. I'm maneuvering to solar null.
Copy, good news.
The views of our blue marble in the blackness of space, now capturing the imagination of a new generation, the Artemis generation.
The untapped scientific and resource potential of the moon is incredible. The lunar environment will help us better understand the origins of our solar system, to prove the in situ resource utilization and technology demonstrations required to reach even further into our solar system. But none of that is possible without first successfully reaching the moon with a human-rated spacecraft.
After TLI, teams used Orion to reach a never-before-attempted, highly stable, but also fuel-efficient orbit around the moon, the Distant Retrograde Orbit, or DRO.
So we're all set for OpNav coming up here in about 20 minutes. Correct. Okay, thanks.
Flying by on the entry to the DRO put Orion within a mere 80 nautical miles of the lunar surface. That was close. And this path used the moon's gravity to slingshot Orion out to a new record for a human-rated spacecraft's distance from our home planet of Earth, nearly 270,000 miles away.
And it was in those harsh environments that Artemis I truly shined, increasing our understanding of how to confidently operate in deep space. On flight day 13, we canceled a planned orbital maintenance burn because it was simply unnecessary. On flight day 20, we ignited the main engine once again and began the long journey back to Earth.
From this view, Orion is 1,277 miles above the lunar surface following its return-powered flyby burn, which sent it around the backside of the moon. Orion now has its sights set on home.
Artemis I set out to fulfill a number of requirements, but the highest priority for this mission was to demonstrate the performance of Orion's heat shield at lunar return velocities. So during re-entry, the largest heat shield of its kind ever made by humans had to prove that it could protect crews from temperatures that exceed 5,000 degrees Fahrenheit. That's nearly half the temperature of the surface of the sun.
Orion hurtled towards the Earth at 24,500 miles per hour, Mach 32, and initiated the first ever skip re-entry. This is the first time that humankind has skipped a spacecraft off the Earth's atmosphere.
For those of us who have flown shuttle, Soyuz or Dragon, coming back from the International Space Station, we wear these Mach 25 patches. This is the return velocity from low Earth orbit. But Mach 32, that lunar return velocity, that's a whole order of magnitude more energy to dissipate. So there we were. Orion had just traveled nearly 1.4 million miles, and it's these last few miles that'll make or break the mission.
We are now in the entry phase.
The team stood silent. Mission control room was deathly quiet as Orion entered the blackout period. And it was tense. We had no telemetry, we had no comms, we had no visual. All we could do was simply wait.
Standing by for a reacquisition of signal. This is the moment of truth for Orion.
And then suddenly there it is.
And there is a view of Orion.
I mean, Orion has survived the flaming hot re-entry. Mission control consoles all come alive with data again. We're on glide slope, the drogues deployed, but again, we're at the point where we're all holding our breath. And there they were, the three big, beautiful main parachutes fully deployed. And we watch Orion gently settle into the Pacific Ocean.
Splashdown. Orion, back on Earth.
We are speechless. We are ecstatic. I mean, we did it. At that moment, we could say, without hesitation or reservation, the Artemis generation, our generation, has had its first flight. We are going to the moon.
Statistics show that even through today, newly developed rockets have a failure rate of 50%. And generally, there is no rocket that performs perfectly on the first flight. And yet, SLS performed magnificently. This vehicle was described by space experts as symmetry in motion. There were 140 planned test objectives in the timeline. Artemis I achieved each and every one with such precision that the teams expanded the envelope with 21 additional test objectives. Because of the Artemis I mission, we retired risks that could have delayed or unraveled the ambitions of this generation, our generation, to return to the moon.
Because of the Artemis I mission, we have demonstrated our ability to go farther and faster than ever before, opening the door to explore Mars and other destinations throughout the solar system. By nearly every single metric, Artemis I was a resounding success.
Just as Orville and Wilbur Wright were the first to achieve human flight, 50 years from now, we will look back and point to how our efforts to venture out into deep space began here. Our voyage out into the solar system started with this first flight.
And yet, this is but a prelude to what comes next.
Ladies and gentlemen, your Artemis II crew.
Human beings will fly around the moon next on Artemis II, simply because of the demonstrated amazing success of this first flight.
Thank you to the NASA workforce. Thank you to our industry partners, everyone in Europe that's working for this.
We need to celebrate this moment in human history. It is the next step on the journey that gets humanity to Mars.
America has made a very deliberate choice over decades to curate a global team, and we are going to the moon together.
When I think about this mission that's a relay race with international partners, it's also so awesome in and of itself. So, am I excited? Absolutely.
Woo! I want everybody to say it. 1, 2, 3. We are
We are all truly part of the Artemis generation.